Okay, so get ready because we're going deep today.
Oh,
Deep into the world of particle physics.
sounds fun.
Yeah, we're talking about CERN, the Higgs boson, the Standard Model.
All the good stuff.
Exactly, and all that mind-blowing stuff about potentially discovering new physics, stuff beyond what we already know.
Yeah, it's not every day we get to peek behind the curtain of experiments like this, really pushing the limits.
It really is like getting backstage passes to like the biggest science show on Earth.
I like that, yeah.
So we found this super cool article, hot off the press from August in the Journal of High Energy Physics.
Okay.
And it goes deep into how scientists are using the
Higgs?
Yeah, the Higgs boson
Rock star.
to like crack open a whole new world of
A
physics.
whole new realm.
Yeah.
It's pretty ambitious.
It is. So let's back up a bit for everybody.
Okay.
What is this Higgs boson anyway, and why is it such a big deal?
Well, so you've got the standard model of particle physics, right?
Right.
Our best map of the subatomic world explains a lot, how particles and forces work together, but it was missing a piece. A big one, something that held it all together,
Okay.
and that was the Higgs.
The Higgs boson.
It's a fundamental particle,
Okay.
and it's the one that gives other particles their mass.
So it's like the final piece of a puzzle,
Yes.
but it also explains why the puzzle pieces all stick together.
Yeah, that's a good way to think about it.
That's amazing.
The Higgs field, right?
Yeah.
It's everywhere, and the Higgs boson is part of it.
Okay.
So some particles get caught up in it, and that gives a mass.
Right.
But others, like photons, they just slip through, so they stay massless.
So it's like
Yeah.
it's like walking through a really crowded room,
Okay, yeah.
and some of us we're bumping into people constantly.
Right, you slow down.
We slow down, but other people just like glide through.
Exactly.
That's a cool way to think about it.
It is, and just like we have, say, the electromagnetic field, and that's what gives us light, electricity.
Yeah.
This Higgs field, it's crucial for the universe as we know it.
Wow.
Without it, no mass, no atoms forming, so no stars, no planets, no us.
Okay. That's
Yeah,
mind-blowing.
big stuff.
So the Higgs is a pretty big deal, but okay, if we have the Standard Model now,
Yeah.
and it's complete,
We think
why are physicists still so obsessed with looking beyond it?
because, well, as good as it is,
Yeah.
it doesn't answer every question.
Oh, really?
It's like you're exploring a room and you realize there's a hidden door.
Whoa, okay, like what kind of questions are we talking about here? What's behind this door?
Well, big ones,
Mm.
like dark matter,
Okay.
dark energy,
Yeah.
that's 95% of the universe.
Wow.
The standard model doesn't explain it,
So our best model
right?
can't explain 95% of what's out there.
Pretty much.
That's kind of unsettling, but also really exciting at the same time.
Right. It means there's so much more to learn.
Yeah.
That's why physicists are so driven.
To go beyond the Standard Model.
Exactly. Find those missing pieces, new forces, new particles.
And where does the Higgs fit into all of this?
Well, one way they're using it at CERN
Okay.
is they're looking for events where two Higgs bosons pop up,
Okay.
and then they decay.
Mm-hmm.
This is super rare.
So they're looking for something that's incredibly rare.
Fair
It's like,
thing.
I don't even know, finding a specific grain of sand on a beach, but the beach is like the entire universe.
And they're colliding near the speed of light, yeah.
That sounds really hard.
Oh, it is.
But is that why it's so promising?
Isn't
Because it's so
sure.
hard to find.
If we see something different, something the standard model didn't predict
Yeah.
with these Higgs events,
Yeah.
that's a sign of something new.
Like a clue.
A clue in a language we don't understand.
Wow.
But it could unlock a whole new way of seeing things.
I'm starting to get why this research is so groundbreaking.
Yeah.
But how do they even begin to
Uh,
look through all that data?
That's where simulations come in.
Simul-
They create a virtual universe inside a computer.
No way.
They use the standard model
Okay.
to see how particles should behave.
So they have a virtual universe based on what we know, and they're comparing that to the real data.
Precisely.
Okay.
And here's the cool part.
What?
If something pops up in the real data,
Yeah.
a bump, a pattern, that doesn't match the simulations.
Yeah.
That could be something totally new, something the standard model doesn't explain.
Like seeing a blip on a radar
Exactly.
could be nothing, or it could be something huge.
It's like a cosmic detective story.
It is.
And these experiments,
Yeah.
they create a ton of data.
A ton.
Billions of particle collisions every second.
That's mind-blowing.
And that's where they need help.
Oh, really?
Machine learning.
Oh, okay. Let's talk about that in a minute, because
Tell me why.
I really want to see how machine learning fits into all this.
Yeah.
But first, I gotta know.
What's that?
Did they find anything?
That's the question, isn't it?
It is. So, spill the beans.
Well, not yet.
Oh.
But that's not the end of this story.
Okay. Tell me more.
It's like we're mapping uncharted territory.
Yeah.
Even if we don't find that hidden city right away, we're still creating this valuable map for the explorers who come after us.
So it's less about instant gratification and more about laying the foundation for future discoveries.
Exactly. And speaking of the future, there's a big upgrade coming for the Large Hadron Collider.
Oh, yeah. I've heard about this upgrade. What's it going to do? How's it going to change things?
Imagine trying to see a distant galaxy. You can use a small telescope, sure.
Yeah.
But a much bigger, more powerful one?
Right.
It would reveal so much more detail.
Makes sense.
That's basically what this LHC upgrade is. It's like switching from standard definition to ultra-high definition.
So we get more data, more details, maybe even more chances of finding something groundbreaking.
Exactly. More collisions, more data, more clues.
Okay, but that also sounds like a huge amount of data to process. How do they even plan on handling all that information?
Well, that's where machine learning comes in. Your social media feed seems to know exactly what you like.
Yeah, it's kind of creepy sometimes.
Yeah, a bit. But it's machine learning at work. Analyzing your behavior, predicting your preferences.
Okay, so how does that apply to particle physics?
In this case, instead of suggesting products or filtering emails, these algorithms are trained to sift through all those billions of particle collisions, looking for specific patterns and anomalies.
So it's like having a team of super-powered research assistants working 24/7.
Yeah, like a whole army of digital detectives scanning through all that data, searching for clues.
That's incredible. But I gotta be honest, sometimes I wonder, why should the average person care about all this? Like, what's the real-world relevance of all this?
It's a good question. And it's one that scientists are always thinking about. It's important to remember that even the most fundamental research often leads to practical applications that benefit all of us.
Can you give me some examples?
Sure, think about the internet.
Okay.
It actually came out of fundamental research at CERN. Scientists needed a way to share information efficiently. And that led to the development of the World Wide Web.
Wow, I had no idea.
And then you've got things like medical imaging technologies, MRI, PET scans.
Right.
Those rely on our understanding of particle physics, too.
Huh.
Without that understanding, we wouldn't have those life-saving tools.
So investing in fundamental research is kind of like planting seeds for future innovation.
Yeah.
We don't always know what will grow, but the potential is huge.
Exactly. And beyond the practical benefits, there's the pure joy of discovery, right? Understanding our place in the universe.
It's like we're all part of this amazing cosmic story.
And physicists are helping us understand it.
Exactly. And this research, even though it hasn't found definitive proof of new physics yet, it's still a big step.
Yeah.
It reminds us that science is a process, an ongoing journey.
It's about asking the right questions,
Yeah.
challenging our assumptions, and never losing our curiosity.
And who knows? Maybe those signals of new physics are just waiting to be discovered in the next experiment. Or maybe by the next generation of scientists. It really makes you think about how much we don't know.
Yeah.
There's so much out there left to discover.
And the tools we're building.
Wow.
They're opening up all these new ways to explore.
So there was this one thing in the article that I thought was super interesting.
Okay, what's that?
It mentioned these theoretical models that go beyond the standard model.
Right, yeah.
And some of them suggest that Higgs bosons, they might actually be produced more often than we think.
Oh, yeah, that's interesting.
What's the deal with those models?
Well, they're still theoretical, of course.
Right.
But they suggest there might be more to the story.
Okay.
Like there could be new particles or forces that we don't know about yet.
Okay.
And these could be influencing how Higgs bosons are made.
So it's like the universe is even more Higgs-friendly than we thought.
Yeah, maybe. It's a cool idea.
It is. So even though this study, they didn't find proof of new physics.
Yeah.
It still feels like a big step forward.
Definitely.
It's helping us narrow things down and focus our search.
And with the LHC upgrade coming,
Oh, yeah, that's right.
10 times the data.
Can you imagine the excitement?
Oh, it's huge.
All that new data to dig through?
It's like giving a detective a brand new magnifying glass.
I love that.
A whole new set of clues.
It really highlights how science is a journey,
It is. It's always evolving.
Full of surprises.
And sometimes the things we don't find,
Yeah.
they can be just as important as the things we do.
Well, we've covered a lot today.
We have.
From the basics of particle physics to these mind-blowing experiments at CERN.
It's been quite a journey.
What really stuck with you?
That's a good question.
If you were a physicist yourself,
Yeah.
What mystery would you want to solve?
I think I'd be fascinated by dark matter and dark energy.
Oh, really?
Yeah, it makes up most of the universe, but we hardly know anything about it.
It's true. They're some of the biggest mysteries out there.
Yeah, and trying to understand them, it would really push the limits of what we know.
For sure. Well, for everyone listening,
Yeah.
if you want to learn more,
Dive deeper?
yeah, check out the show notes.
We've got links to the article.
All kinds of resources.
Keep exploring.
Thanks for joining us on this deep dive into the world of particle physics. It's been a blast. Until next time, keep those minds curious.
Stay curious.